Hi, in this video we'll be talking about unlocking polyphony with artificial intelligence. All around the world people know the Flemish primitives, Van Eyck, Bruegel, Bosch, masters of their craft with names that resound until today. But do you know of Dufay or of Josquin des Prez? Well, both are Renaissance composers, specifically so-called Franco-Flemish polyphonists. Polyphony is music with multiple voice lines, lines that interweave in dissonant discourse or come together in sweet harmony. Dufay, for example, is considered to be of the first generation of European musicians who are primarily composers by occupation. Dufay had a cosmopolitan style and an extensive oeuvre which included virtually every polyphonic genre of his time. Dufay was held in such high regard that it was his work, Nuperosarum Flores, that resounded during the consecration of the Florence Cathedral. Later in the Renaissance came Josquin des Prez. Josquin is considered one of the greatest masters of Flemish Renaissance polyphony. He developed a style of expressive and imitative movement between independent voices. Josquin's music was so well and widely liked, he was probably the world's first famous musician. The Franco-Flemish polyphonists laid the groundwork of Western music and were great Flemish export products of their time, much like the Flemish primitives. Yet, unlike the Flemish primitives, they seem to have faded from collective memory. What happened? And what can we do to reintroduce and popularize their beautiful music today? Well, there are a few reasons why people, including professional musicians, are not familiar with Renaissance polyphony. Let us take a look at a few reasons for this lack of popularity. To begin with, not a lot of music has been digitized. Moreover, all music is written on old books, and while some of these books are in pristine condition, others may be subject to great degradation over time. What's digitized is often not transcribed to modern notation. Instead, it is written in an old and difficult to read music notation system called mensural notation. Other challenges are of the data analytic kind. Who wrote the piece? Or as musicians call it, to Josquin or not to Josquin. Furthermore, what motifs do we recognize in the piece? Are there any lines borrowed from other composers or from older music, so-called plain chant? In my research, the old and new meet as Renaissance polyphony is unlocked with the power of neural networks. Let's delve in a little bit deeper. The main problem musicians face is the problem of transcription. But transcribing music is a painstaking task. Every symbol on every page needs to be read, decoded, and written down. Wouldn't it be great if an AI could do this for us? Let's take a look at a relatively simple example, D'un autre mer, a chanson written by the Flemish composer Johannes Ockeghem. To get a transcription, we must first perform an object detection task. First, we detect the staves. Then, an ensemble of neural networks detects symbols. We use an ensemble because certain symbols are more rare than others, and when we have a mixture of experts, each specialized on their own set of symbols, we get better results. Then, when we have detected symbols, we can detect pitches and staff lines around them. And this is how things look when we digitize the information to a sheet. After object detection, we are not yet done. Indeed, the notation system of polyphonic music, mensural notation, is difficult to read, even for musicians. This is because there were no measure bars, making voice alignment much more difficult. The note value is not given directly by the note shape. A note duration is dependent on the shapes of the surrounding notes. So, now we have a constraint solving problem with a special kind of language, the language of polyphonic music. Therefore, next to computer vision, also natural language processing techniques play a role in this multidisciplinary research. If mistakes are still present in the transcription pipeline, we give the user the option to make corrections. In other words, the user, be it amateur or expert, still can be and sometimes must be in the loop, but the AI did facilitate the task greatly. Finally, after having applied computer vision, NLP techniques and domain knowledge, we can make a transcription and unlock a bit of our heritage. The result sounds a bit like this. Another topic of interest is digitally restoring the folia. With a type of generative model called a diffusion model, we aim to denoise images in a specific way. We can get rid of creases, ink bleed through, bring back faded staff lines, deskew staffs. In other words, we can at least digitally turn back the hands of time. In doing so, we can decrease the error rate of the transcription pipeline. Moreover, in future work, we attempt to override the old notation on a page with modern notation. This is to say that with diffusion models, we can use the original page with often appealing and ornate layout and replace the old notation with modern notation, thereby lowering the threshold for performance and aiding in the spread of our Flemish heritage. After reading our digitized sheets of music and building a database, we can now perform music analysis. For example, to attribute a composer to an anonymous work, we perform a sentiment analysis. Indeed, our task is similar to labeling tweets, for example, as negative or positive. But instead of feeding tweets to the model, we give it melodic or harmonic excerpts. We let the model build a representation of a piece, deduce what's important, and hopefully find out who wrote the piece by comparing it with a database of composers and their works. To conclude, as humanities are rich, multidisciplinary, fuzzy and intertwined, we see this reflected in our AI problem-solving approach. NLP, computer vision, domain knowledge, generative models all assist experts in unlocking our wonderful cultural heritage.